So I think what we'll do is we'll go into discussion and maybe seed the discussion with a question for Gautam, if anyone has a question for Gautam. Guillermo.
Hi, Gautam. Great talk as usual. A lot of information, a lot of work here. So I was wondering, what's your take on evolving training sets? So whenever you deploy a machine learning model after a month, it may get obsolete because the training sets have changed.
I mean, my thought on evolving training sets is, we're going to have to evolve training sets. And we've already started looking at a Elastic version 3 that will include spectroscopic time series. That's the big improvement that we've been doing for the Selden stuff to train the spectroscopic modality. And it will hopefully have the updated Rubin cadence. And we know we have to update some of the models in Elastic. So we'll do so. And I think we want to mix in some real Rubin data, but again, not give you any indication of what that is. I would love to also put in host galaxy postage stamps because we know folks want that. And I think this will evolve over the course of Rubin. I'd like to make it so that you press a button and you get a new training set once a year, maybe once every 6 months or something like that. And that's the cadence on which we're going to be having to retrain these models. And that is a cost that we're all going to have to accept.
Thanks.
Okay, so these are the discussion points for the next 7 or 8 minutes. And I think they overlap a lot with what Gautam was talking about, particularly things like, tools interfaces between optical brokers and other systems. Do we think foundation models or multimodal models are the solution to that is going to work across the SED, fill in the gaps where we don't have the data, allow us to marginalize over that sort of thing?
The rest of my panel isn't even up here, but
well, there's no panel, but I mean, the people who it's a discussion. So if you have, please, I mean, if you have comments on that.
Do I think foundation models are the right answer?
Yeah.
No. So I think one of the issues with foundation models, and one of the reasons they came out of industry, is that they're very powerful for language, where the correlation length scale is actually fairly low. Like, you can begin a sentence like, it was a, and there's many, many different ways to complete that. But in physics and astrophysics, if you see a partial light curve, you've narrowed down the future evolution considerably more because the correlations are much stronger. These models don't know about physics. There is a different kind of architecture, specifically something called a world model. If you heard the term JEPA from a guy named Jan LeCun, you probably heard about this. You can put things like physical constraints into the model. It knows what redshift is. It knows what wavelength is. So the team I lead in Sky is now the flagship team. We are going to be trying to build that in the next 3 years, along with Adam Miller and some of your other collaborators. Early results already seem pretty promising. The world model approach, to my shock and horror, seems to be learning about Rubin wavelength from passband names without us putting in wavelength information. It seems to be segmenting classes into things that are more physically motivated than morphology motivated. Will it work? I don't know, but I'm pretty certain it's not foundation models, because foundation models were what you had for language, and light curves are not language.
Anais.
I'm not in the panel, but I have a comment to complement what Gautam said.
This is not a panel, this is a discussion session. So
excellent. So I think the question is, when we do, like, LLMs are amazing, foundation models are amazing to do a bunch of things. But if you want to have reproducible results, those are not the ones that you're going to use. And as scientists, we want to reproduce results and be able to constrain what went in and what went out, and being able to redo it in a couple of years and have still the same result. So we should not forget of still evaluating reproducibility, robustness, reliability. All these are very important things for science.
Explainability. Explainability as well.
Exactly. So while I use LLMs every day to generate code and not
still hiding in the room somewhere? Is Rebecca still in the room?
It's Rebecca.
She ran away.
No,
So Dovecki, the thing that she talked about today was the reprocessing of DES 5-year, and it reduced the significance, as you know, from being in DES, of the DES cosmological tension results.
Yeah.
Okay, was that reproducibility? No, that's not
no, but
exactly
we,
the same result.
but we
You
can.
want to evolve.
No, but it's very different in the sense we know what changed in the analysis and we can reproduce still the DES 5-year results. What changed with Dovke is the calibration, is how we treated the light curve. So it's still reproducible, but an LLM, you ask it the same question twice.
So,
Give you
so
two
what you,
different
so what you
answers.
want is to be able to characterize the change that comes from a model.
Yes,
And
exactly.
I don't think that's actually that hard.
Give the microphone to Shishri.
It's good that you bring up world models. That's quite important. But I don't think that that really contradicts foundation models. So foundation models for language, yes, but light curves, we can have foundation models for light curves. The
Yeah.
ones that are out there are more for regular light curves, not
Yeah.
very good for astronomy. But I think
Yeah.
having those going in there.
The,
will also-
the language is also really messy with world models because they are so bleeding edge that nobody quite agrees on exactly what they are. A lot of people are saying world models are just a special class of foundation models where you put in extra constraints and an energy-based loss function.
No, I think what Jan LeCun specifically says is that
Yeah.
when we talk of generalization for foundation models, meaning think of humans, we are not general.
Yeah.
We specify or go into some specific niche areas. We cannot expect models to be generalized.
Yes. And another motivation to move in that direction, of course, is that Jan LeCun now has a $1 billion startup. So if you are a grad student or a postdoc, probably a good thing to work on world models. By the way, we're hiring.
So, I mean, to extend this a little bit more to some of the stuff we were talking about the interoperability between the multi-wavelength and the multi-scale. Do we think that the ML tools, some of the stuff that Gautam's doing, some of the stuff that the rest of us are doing, are those going to fill in those gaps? Are those going to help us figure out where the gaps are? Do we just go to Claude and say, okay, I need the code to write this missing tool to do blah, 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 blah. It'll generate it. I can write it. Is that the way forward? We don't need to worry about hiring programmers anymore. Guillermo?
So, I think they're great tools, but you need to know how to use them. So that means from let's say from a computer engineering point of view, you basically need very good software architects that can communicate with Claude Code or something like that in order to make sure that what's being developed is maintainable and that it's properly coded. But in principle, you may need less programmers, like hardcore programmers in the future. But you will need people thinking about how software is going to be built.
Anais, I think you have an opinion on this?
Many opinions. I agree with Guillermo. You will need to still to supervise what the code, like you can be an excellent prompter and have a code that almost does whatever you want, but you need to prompt it properly. You need to have the skills for it. And you also need to be able to evaluate the code critically. What I'm afraid for the next generation is that many of us are able to do this vibe coding very well because we have years of experience debugging code. So we know where it may fail. What scares me is if we only rely blindly on vibe coding to generate tools, we lose those criteria of critical review on the code. And I think for newer generations are learning to code, this will be very hard.
So it's worthwhile thinking the folks who've advertised this afternoon that they're looking for postdocs and grad students who can code, that there is still opportunity there that the LLMs will not take away from us for at least a while yet. And so at least these tools will be human written or partly human written, but not generated.
Add one thing.
Sure.
This isn't even on the slide, but I am very aware of the shift that's happening. And for me, living through the IDL to Python 2 shift, it feels the same. I don't think people need to learn SQL anymore as a grad student. And so within Desk on April 6th, we're doing a seminar on using agentic AI for coding in the Desk pipeline context. And we've got two of our pipeline scientists who are paid by the DOE, trained to do this, to teach our junior members this, because I think it is the time. And I am working on putting it into our curriculum at the University of Illinois. I don't know how many other people are doing that, but when the tidal wave comes,
Entire
yeah,
separate
yeah.
discussion.
Yeah, no, I think the tidal wave is coming, and so it's better to just get ahead of it.
Is one point from some institutes, I know, but yeah. Okay, I think we'll leave it there. But you've got to you've got to walk to dinner, though it's not actually that far. So let's thank again all the speakers from this afternoon's session.